I've got question 58 on the board. That's an even numbered problem from your text. Again, the very first thing I'm going to do when I have log equations is I'm going to look at my arguments, and I'm just going to record that they have to be bigger than 0. So x has to be bigger than 0. X minus 10 has to be bigger than, has to be bigger than 0, which means x has to be bigger than 10. And x minus 18 has to be bigger than 0, which means x has to be bigger than 18. That's actually the only one I'm really going to need to check, because of course anything that's bigger than 18 is also bigger than 10, is also bigger than 0. Okay, but make sure that you've written down all three inequalities. If you just write down one, it's not clear to me that your thought process was, oh, that's the one that's going to become the most important. Make sure you've written them all down. Okay, so now if I look at this, every single term is a log. I don't have any terms that are just numbers. And I've got logs on both sides. So I think this might be a good one to get log of this equals log of that, and then I can just say this equals that. Now the right-hand side is great because it's already just one log. Notice all of these logs are the common log. That means it's base 10. Okay. All right, over here on the left, I have two logs added together. When I'm adding logs, I'm adding exponents. You might be sick of me saying that. I'm going to keep saying it anyway, because it really helps me to remember why the rule works. So I'm not just memorizing and blindly manipulating things. I'm saying, hey, logs are exponents. I add exponents when I'm multiplying. So I can say this is 1 log for the product x times x minus 10 equals the log of x minus 18. Let's do that multiplication. So the log of x squared minus 10x equals the log of x minus 18. Log functions are 1-to-1. So if the log of this is the log of that, this is that. So x squared minus 10x is equal to x minus 18. Excellent. Now, that's a quadratic. Notice, from here, it doesn't look like there are any restrictions on x, so I'm glad I wrote them down while they were still obvious. And again, I do that first. If I ever forget, I've got the whole time I'm working through the problem to remember it. All right, since this is quadratic, I want to move everything over to the other side. So I'm going to subtract over x and add over the 18. So we'll have x squared minus 11x plus 18 is equal to 0. So let's try factoring. An x and an x. Numbers that multiply to give me 18 would be 1 and 18. Integers that multiply to give me 18 would be 1 and 18, or 2 and 9, or 3 and 6, 4, 5, 6 is already on the list. Okay, now they're going to have the same sign, so I want them to add to give me 11, so it looks like 2 and 9. I want them both to be negative, so that when I combine my outsides and insides, I get negative 11x. So we'll have negative 2 and negative 9. Okay. So then I set each factor equal to 0, so x minus 2 equals 0, or x minus 9 equals 0. That would give me x equals 2. This would give me x equals 9. So those are my two candidates for the answer. Now I have to check, are those values that would make these arguments positive? Are they bigger than 18? No. And no. Notice, both x values are positive, so this log is defined, but this log isn't. And this log isn't, because they're not positive enough to make the arguments positive. So I reject both of them. Now, I still have to answer the question. What are the solutions? There is no solution. Make sure you write that. Don't just cross things off. Have a bunch of work with no answer. That's the answer. Or in set notation, it would be the empty set. So you could put a set that is literally empty, or what looks like 0 with a slash through it also means the empty set. By the way, because that means empty set, that's a horrible way of writing 0. Okay? I know sometimes people get in the habit of, to distinguish the number 0 from the letter O, they put a slash through the number. That's great if you're in a situation where you're writing lots of zeros and lots of O's and never the empty set. You're at the point, pre-calculus and beyond, we'll be using the empty set symbol, and we're not going to be using the letter O a whole lot. So don't use that to mean zero, that means empty set.